Well, guys, in the next part of this lesson, we're going to be looking at what we call the straight line graph, or what we call the linear function. Okay, I'm going to go right back to grade 10 days, even 9 days, and revise this extremely important concept, the concept of a line. And if you remember, its general form would be some books use ax plus q, others would use y equals mx plus c. If you remember, that was the gradient. Just to briefly revise it, we'll comment on that in a moment, and that was the y-intercept. Okay, that's all earlier work, but we're going to look at that in this lesson as well. Okay, and I think we'll plunge right into an example quickly of sketching graphs like this. Okay, now if we have a look at this, let's have a look at the first example quickly. Okay, in the first example, we're going to be having to sketch the graphs of the following. Okay, we've got fx is equal to x, okay, and then we've got, and let's draw that line first, and then we're going to have to do gx is equal to 2x, and we can use, say, hx. Notice you don't just have to use the symbol for f, but you can use g. It means pretty much the same, h as well. So let's have a look at the graph of y equals x. Okay, so if you take y, remember that is the y value, the f of x is equal to x. Now let's pick some values. Okay, you can do whatever you like. We can use minus 2, minus 1, 0, 1, and 2. So the x's would be exactly the same as the y, so these would repeat themselves. Okay, so if we plot this, we get negative 2 start here, go negative 2, negative 2. It sorts out this one. Negative 1, negative 1. So it's start at 0, go negative 1, negative 1. 0, 0 is easy. And then 1, 1. There we go. And 2, 2 is pretty easy. 2, 2. And there's your line. And you can, of course, obviously draw a line through here with your ruler, and you have the graph of f, that line. Okay, let's suppose we do the graph of y equals 2x. That would be the graph of g. Well, let's pick some values as well. If we have a look here, we can take some x's. Let's make these x values. If we sketch that graph, we can make it, say, let's go again, negative 2, negative 1, 0, 1, and 2. Now, how do we get the corresponding y values? Well, we've got to go 2 times these x's. So you multiply all of these by 2. So 2 multiplied by negative 2 is negative 4. You're doubling. 2 times negative 1 is negative 2. 2 multiplied by 0 is 0. 2 times 1 is 2. 2 twos are 4. Okay, very basic stuff from grade 9 days, but it's important that we revise it. Okay, let's plot these points. Start here. Negative 2, negative 4 is there. Interesting. Negative 1, negative 2. 0, 0 is there. 1 and 2 is here. And 2 and 4. X is 2 and 4 is there. Now notice the line here is a little bit more interesting. It sort of goes like this. Comes up. And it goes there. So it's a little bit sort of steeper than whereas the black line is a more flatter line. Okay, and what about, let's try, for example, the other one, which is number h, which is going to give you y is equal to 3x. So let's have a look at y is equal to 3x. Let's pick some values for x. Minus 2, we made those up. And if we multiply each of them by 3, negative 2 times 3 is negative 6. This is negative 3, 0, 3, and 6. Now we can plot these as well. Minus 2, minus 6. Let's see how that goes. Minus 2, minus 6 is down here. Then you've got negative 1, negative 3. So it's negative 1, negative 3. Then it's 0, 0. Then it's x is 1, 3, and then 2 and 6. And then this line will also now look a bit more steeper than the others. So that line goes up there. There we go. You would best do it with a ruler. And there's your graph of h. Okay, and this is g, and of course f would be this guy here. Okay, and we've represented those points. Remember, the x's are the domain, the y values are the range. Okay, now looking at this, what do you observe about these things? Can you see that the coefficient, if you look at this, the coefficient of x is positive. And it's getting more. Look here, 1x, so it's 1x, it's 1x. The blue is 2x, and then you've got the 3x there. So the coefficient of x is positive. The lines are sort of kind of sloping to the right. They lean to the right there. Okay, and what actually happens is if you think of the line, this graph of h, if you take the points, they're actually being stretched further away from the x-axis than the other two. If you look at this, the 3 is much higher way up on the line compared to the other two. So the important thing, if these guys here, if the coefficients are positive, the lines, of course, always slope in that direction. They lie in that direction. Okay. And if you'll notice that as the value of a increases, this number next to x increases, the line gets closer. It sort of tilts closer and closer to the y-axis. And by the way, these are called the gradients. And I want to show you something very interesting. If you have a look at this, I want you to focus on one of the lines. We can take, say, let's take y equals 3x, which will be the purple line, and I want to show you what the gradient means. So stay with me. Let's have a look at that in a little bit of detail. What is this gradient? I know we did it in analytical, but let's look at what it means. Okay, so if we took, for example, let's take the graph y equals 3x. Okay, now let's explore this number next to x a little bit. We call it gradient. The line is going right, but what causes it? Well, very simply, I want to show you something that's very, very cool. If you take, for example, I want you to look at this. If you go from here, take those 2 points there. Now watch this. There, if you look at the way that how do the y values change? The change in the y values, how do they change? Let's have a look at that. Well, the y values go from 0, remember this is the point 0, 0 there, and this is the point 1, 3. Now the y values have changed from 0 to 3. Okay, so in other words, they are increasing, so they increase by 3 if you go there from here to here. Then if you take the x values, what is the change in the x values? Well, have a look at this. The x's go here from 0 to 1, 0 to 1. So they increase by 1. Now if you look at the definition of sort of gradients, it talks about the gradient of the line. The gradient is simply the change in the y values divided by the change in the x values. Now if you think about this here on this one, what were the changes in the y? The changes went from 0 all the way to 3. So we increased by 3. We went plus 3. Then the x values, the y values changed by 3. If you go there, look at that. This going up here and then across is by 1. The x values have changed by 1, which gives you 3 over 1, which is 3. So the gradient, the coefficient of x, tells us the kind of rise over the run, or how the y values change in relationship to the x's. And that's really what gradient is. By the way, you could also do it from another perspective. Watch this. Say, for example, I gave you this here. Let's take a different color. If you took these 2 points, have a look here. If I went from 0 to 6, okay, if you take that, so I started at 0, and I went to this point here. This is the point 2, or let's say 2 and 6. So if I took the point 2 and 6, and let's go here, 0 to 0. If you take between those 2 points, what would be the change in the actual y values? It goes from 0 all the way to 6. So the change is positive 6 over, and what was the change in the x's from 0 to 2, which is positive 2. Once again 3. If you remember in analytical, you said the gradient was 6 minus 0 over 2 minus 0 there in analytical geometry. But this is a nice explanation of the change in y, change in x, which is really, if you think about it, it's actually 6 minus 0 over 2 minus 0, exactly the same as you do, the y2 minus y1 over x2 minus x1. But there, that's the important thing there. So the gradient is 3 there. What a pleasure. Now, people, what I'd like you to do is to sketch 2 lines, to actually draw 2 lines using the table method, and let's see how it goes, and let's see how the gradient works as well. So try the practice examples. Let's see what happens. Okay, there it is, guys. Sketch those 2 lines. Fx is a half x, and gx is 1 over 4x, a quarter x. Give it a shot, and we'll talk about it in a minute. All right, so okay, let's sketch the graphs. Okay, the first one we can maybe look at here, let's see, is this one. Okay, if we take here y is equal to half x. Now what I'm going to do is I'm going to pick some x values, my domain, my x values. I'm going to pick at random. And I'm going to use nice values. Let's suppose we chose x as minus 2, 0, and 2. The reason why I'm choosing these, if you chose x as 1, you're going to get fractions, and I don't want to really do that. Okay, so let's have a look. What would the y values be? Okay, interesting. Well, if you look, what is a half if you plug in negative 2, or a half if you plug in 0, or a half of 2? These work out, the range values work out beautifully. Minus 1, half of 0 is 0, and half of 2 is 1. So there's your x values there, which is rather nice. And what about these guys here? Let's have a look here. If you chose, like that, we'll go down here quickly, then we're going to plot those graphs. Y is equal to a quarter x. I'm going to choose my x values. Why not negative 4, 0, and 4? And you'll avoid the fractions. If you have 1 or 2, that's not nice. So the y values would be, very simply put, let's have a look here, a quarter multiplied by negative 4 for that x, a quarter multiplied by 0, and a quarter multiplied by 4. So this gives you negative 1, a quarter times 0, 0, and a quarter times 4 is 1. Now we can plot these points, which is a rather good idea, and let's see what the graphs look like. Okay, let's see how the graphs go. If we take the first graph here, which is our blue graph, let's go to color blue, and we'll plot the x points. That's negative 2 minus 1. Okay, so negative 2 minus 1, there, 0, 0, and 2, 1. Okay, let's just check that. 2, 1. There we go, 2, 1. So that's sorted there, domain and range. Okay, and then we can simply draw the line in like that. There we go, and we've got, so that would be the graph of f there. Okay, now let's go to purple, and let's see what the other graph looks like there. This will be, for a quarter, would be minus 4, minus 1. Let's see, negative 4, negative 1, and then what is it? 0, 0, and 4, 1. Okay, 0, 0, and 4, 1. 0, 0, and 4, 1. So if we look at that, have a look at that. Wow, there we go. There's the graph of G. Now look at this. If you look at the gradient of f there, which is quite interesting. What is the change in y? Is 1. So the gradient, the y, remember you got y equals mx plus c. By the way, the gradient is positive. You increased by 1, and you then went across. The change in the x's is 2. And guess what? That gives you a half, which is exactly what it is. The line sloping to the right there. Look at that. Okay, what a pleasure. Okay, guys, and likewise with this one, you can find the gradient as well. Notice that that's the gradient, which is a half x, and your y-intercept c from earlier years. That's where the graph c is, where the graph cuts the y-axis, is equal to that. And there we go. This concept of gradients is very, very interesting. Done in analytical, but very worthwhile in algebra when you sketch lines. Okay, cool. Right, guys, stay with us. We're going to be back for some more linear functions on Cell School.